Grandmaster for wire soup and where you put a bunch of shit and then boil it?
No.
So like
Is it on the stream?
sweet potatoes.
Yep. Oh, yeah. All right. Hello, everyone. I hope it works properly. So today I'm going to talk about cryptography and SSL, and my talk is going to be followed by Matt later on. And so first of all, whatever I talk about in this session, please don't use this for malicious acts or on a hardware or equipment or software which you don't own or don't have a authority or license to use for. And we can't be held accountable for actions you do, which we show in this presentation. So, table of contents, we're going to talk today about. So, what is a cryptography? What is the history of it? Why is it needed? How did it came into existence? A few examples. Modes of cryptography, so symmetrical, asymmetrical, and hybrid, and cipher suit, and a bit of SSL certificates. So to start things up, what is cryptography? Where did it came from? So no computers are fully secure. There's always some kind of a mistake or a hole in the security which is exploited by malicious users. So it might be in the software, it might be a human factor, it might be a hardware which is or can be exploited. We see it happen every day. So what is the cryptography? It's basically taking a plain text data and make it unreadable to hide it for privacy reasons. The initial history of it, how it came into existence, for example, take an example of Caesar cipher. So back in the day, during a war, the information with the letters wanted to be transferred securely, so in case it got captured, it wouldn't be able to read or understand what is mentioned in it. So this is how the Caesar cipher came into play. So what he did basically is you have a casual alphabet, A to Z, or Roman in that case, and you shift a letter of a word, of the letters you use by few positions. So those positions which by you shift is called key. So for example, A with a key with 2 would be C. So that is the case. And what is used for is, as I mentioned, for security, integrity, and reasons. So the data, the plain text, for example, wouldn't be read. So there are two main modes of cryptography. So it is encryption and hashing. So I slightly mentioned encryption a bit already. So it is taking a plain text and running it through with the encryption key and producing an encrypted text. So that encrypted text is called ciphertext, and you use the same key to which I'm going to talk about in a bit. You use a key to decrypt it, and you get the plain text. So you encrypt it into a ciphertext, which is basically should be unreadable. Well, we'll see if that's the case later on. And you use a different or same key to decrypt it and get a plain text, so you can actually see what's information was sent for, like what your friend sent you, and if you can actually read it. What hashing is taking a plain text and running it through hash function, and you get a hash text. It's a single way, so it can be reversed because of the hash function functionality. So it can be reversed. It's single way and it's capped size. So for example, you have a plain text of some few words, but the hash function is set to be 254 bits or however, which hash function you choose. So it might run it multiple times, multiple cycles through the same word, and it will do it until it produces the set size which you chose for a hash function. So what is there's few examples of it. It is RSA and AES encryption methods, and AES is advanced encryption. And there's SHA-1, SHA-2, and Tiger, which some of them are considered insecure at the moment because of their nature of working. So there are quite a few of them, like SHA-252, which are way longer. And if you want to brute force it, it's gonna take a really long time, like billions of years. So, alright, maybe not billions. So I'm quite wrong there. But it's definitely not efficient. So you just have an insane amount of data which you can brute force, so you might look for other methods. Well, the hashing algorithm is capped size. It's quite used in business scenarios. So what companies usually do is, if they have an insane amount of data, just loads and loads of data, they use it to compare or find the hashing values in a data set. So for example, you take a plain text information, you need your company details or personal information need be, and you run it through the hash function, you get a hash text. So whenever you try to run the hash function with the same text, so let's say a word hello, so you hash a hello word, you get a hash text. So every time you would take a hello word, it will produce the same hash text. And if you change a letter from H capital to H lowercase, or one letter in the word, the hash text changes completely. As in encryption, decryption, it changes compared to the encryption method. But there are some things which can be exploited, so it can be brute forced, so taking every guess into account and trying to just brute forcing and finding the decryption and encryption key and finding out what was the plain text when you try to do it on encrypted text. And so this way, if you have an encrypted text, and for example, let's take English language in this case, the most frequent letter is E. So if you have a lot of same letter in your encrypted text, or for example, very common word the, 3 letters, so you'll see like, and for example, let's take X, and X is very common in your encrypted text, for example, and you see 3 random letters and the last one is X, and it repeats through the whole text encrypted message. You could assume that the letter E in the plain text is the X in encrypted text, for example, and using the ASCII table you can just count the difference between those 2 letters, the distance, and that is your key in a Caesar cipher, for example. But in other ones it's a bit more complicated than that. So there are two main methods of encryption. So it's symmetric versus asymmetric encryption key. So symmetric is both parties share the same key. So for example, John wants to send a message to Ethan, and he encrypts it with the key he has, and it gives the same key to the Ethan. John gives the same key to Ethan. So you have a message, you encrypt the one key you and your friend has. You produce a ciphertext, which is gibberish, because it's your message mixed with a key ran through encryption process, and your friend gonna use the same key to reverse the process. So as you can see, encryption is a two-way process. It can be reversed. You have it just having a key, while asymmetrical is having a public and private key. So everyone has a public key. So in the communication sense, everyone has a public key. So you have a plain message, you encrypt it with a public key, you produce a ciphertext, as you can see in a picture below, and you create a ciphertext. Then you give your private key only to receiver. So the sender doesn't necessarily need a private key. Only a receiver gets a private key, so he can decrypt the message, which is ciphertext, and reverse the message which was being sent to him. So this is the main workings of encryption. There are a number of smart and different methods of encryption and hashing, which are used in our real world in companies every day, as for example advanced standard encryption, and we're gonna follow it by CipherSuit. So security, compatibility, and performance of HTTPS. So it's basically CipherSuit is used for HTTPS communication. So CipherSuit defines how the performance, the capability, and security of your HTTPS. HTTPS is known as a secure connection compared to HTTP, which is nowadays trying to get rid of as fast as possible, and majority of websites are going to HTTPS. So when you establish a connection with any web server, you're gonna exchange a CipherSuit, which defines how fast, what kind of system they're using and what system you're using, and they'll check if it's compatible. It is and security, how secure it is, what kind of encryption methods you use. So as you can see, here is in different colors, it's a CipherSuit. So the first, you have a key exchange algorithm. So this algorithm which defines what kind of a key exchange method the website is going to use to communicate with each other. So the CipherSuit is used for security in the manners to hide the data from malicious users, login details, passwords, and other sensitive information. ACDCA is the purple color on our line, is authentication algorithm. It is used to authenticate if this website is legit, and to double check it with SSL certificates. So you need to see the compatibility between those two, and you need to look for quite a few ones to find if the CipherSuit is matching on the other side, the server side. The AS128 is a bulk encryption algorithm, so this is just defining what kind of encryption and the strength of AS you're going to use. So keep in mind with the stronger communications algorithm encryption you're going to use, the slower the connectivity and other performance is going to be, because it's going to take way more not performance of the power of the machine to process it. And the SHA-256 is a MAC algorithm which is used for encryption purposes as well. Followed by that, we have SSL certificates. So why do we need them, and how do they help us, and what are the types of it? So basically, SSL certificates is making sure that while you connect to a website, it is a legit website, and it is considered secure, which is not always the case. They help us to determine if the SSL certificate is valid, encryption is there, basically to make sure the connectivity to the website is secure, and you get to know the location of the company or the server, or in that case organization name and other details. They have the three types, main ones. So domain validated type is the least secure one, which is the most exploited by malicious users. It's usually the case where on a domain server, these SSL certificates can be created, so the domain server can give them. So if a malicious user has a connection or entry to the domain server, they can just produce them, and so they're very not secure, and they can be forged with access to some specific hardware or software. Then we follow that by organizationally validated SSL certificates. So these are more in depth. To get the certificate on a website, you'll need some information of a company, so the location of a company, the maybe lead company owners details, where they go, or how they storing data, and these things come in together, and the organizationally validated websites get this certification. The extended validation one is the high-end one, the most secure one. So to get this validation for of SSL certificate, you need to go through a whole background check. So it's the most secure one, and this one, extended validation one, is used for banks, government websites and such, because of its highly risky data which is being transferred in them. So to get this one, you'll need a full background check, and you'll be granted it. And using these SSL certificates, the whole communication is based around security. Encryption is included in them, as well as cipher suits. So this is basically what I wanted to present today, and yep, if you have any questions, I'll be more than happy to answer them. I hope you enjoyed, and my talk will be soonly followed by the math talk. Yep. Do you have anything in chat or in class? Any questions?
Rodney, do you want to quickly talk about SSL stripping?
Not really.
Not really? So there is a...
Yeah, come here, come closer. You're by microphone. Thank you, Matt.
So there is a kind of attack called SSL stripping, which allows you to basically remove or replace the HTTPS header and replace it with your own cert. So Ryan did a talk on this last year which kind of used it a little bit, which was on the Android phone, where he was manning the middling and stripping out the certificate to be able to read and write data that was on his phone. Was it remotely?
Yeah.
Yeah,
I was
so-
in the connection on my phone because it was my phone. You wouldn't be able to do it normally, but because I have full control over it, I could install extra things. Yeah, but it's quite handy for working out what the hell an app's doing in the background and stuff.
So it's really good for when you're doing reverse engineering or malware analysis and stuff like that. So if you've got a malicious app in the background and it's encrypting what it's doing, you can use SSL stripping to then gain access to the underlying calls that it's actually making. So if it's calling to a web server, it's a lot easier to see what the fuck it's actually doing, because it is calling now in clear text instead of encrypted text. So that's just not anything, just an addition to why we're talking about SSL and stuff. So it is useful out there.
HTTPS process is insane for certificate validation, because you need trusted certificate authorities, which are either really expensive or really hard to set up, and also they need to be trusted. Sometimes you can fake these certificates if you have certain information, which I'm not going to get into. Probably will get into it later. Probably I'll do a lecture on how the whole SSL HTTPS authentication works and how they actually authorize that certificate and make it. But that's for another time. This is just basics.
Yeah, get you a little bit